If a mass hanging from a copper wire, as shown here, is displaced a little bit from its equilibrium position, it would oscillate up and down by a tiny amount because the wire would act like a spring. We're asked in this problem to find the period of that oscillation. In order to do this, we need to look at the stress-strain equation, which I have written here, and compare that to Hooke's law. Hooke's law says that the force is equal to a constant times a distance away from an equilibrium position. If we look at the stress-strain equation here, we can multiply by area on both sides to get something that looks similar, where we have a force on the left-hand side, a constant term, and some change in distance. What we'll want to do in this problem is treat this cross-sectional area times the Young modulus divided by the unstretched length of this wire as the spring constant, and then use that to find the period of oscillation. Doing so, we plug in the expression for the cross-sectional area in terms of the diameter, so that would be pi times the diameter divided by 2, quantity squared, and plug in then all the numbers given in the problem statement to find that the spring constant of the wire is 4.32 times 10 to the 4 newtons per meter. Now that we know the spring constant, we can find the period of oscillation using this equation here. Plugging in the value for the mass and the spring constant, which we just found, we find that the little mass would oscillate with a period of 0.068 seconds.